Make sure you have some paper with you.
Sorry for the interruption. Any students that will be participating in the blood donor clinic today and have not yet handed in their permission slip form need to report to the blank form class immediately. Please do so. It is room 2E4. Thank you.
Who are my left brains? You'll appreciate I got brand new markers yesterday, like I get to open them for the first time. They'll be all sharp. Definition. You probably saw this in grade 9 and probably didn't care about it, but here's the definition of what makes a function a polynomial. A polynomial function is an expression in which all exponents of the variable are whole numbers. Polynomial is an expression where all exponents of the variable are whole numbers. So an example could just be our base quadratic x squared. What makes that a polynomial? It doesn't have to be more than 2. It just can't be a fraction. That's what this definition is saying. It has to be a whole number, so something that's even and is one of our counting numbers. An example could be 3x cubed plus 7. Again, what makes it a polynomial is that the 3 is with the x and it's not a fraction. We could have negative 4x to the 5 plus 3x to the 4 minus 2, for example. It's not saying the coefficients can't be fractions, so we could have 1/2 x to the 7. It's just saying the exponents can't be fractions. Why not? What if we had an x to the 1/2? Why is that not a polynomial? It's not a whole number, and back in grade 10 you actually looked at fractional exponents. So x to the 1/2, if you think way back in your memory, what's that equal to? X to the 1/2 is the same as what? Square root of x. So those are rational functions that we did last unit. That's why they have to be whole numbers, otherwise there's some kind of other function. Today we're going to look at dividing. The reason we need to do dividing is because next class we'll look at factoring. The reason we need to do factoring is to be able to graph. So this is all coming down to let's graph polynomials. You're going to love this because it's super easy. So example 1, divide f of x equals x to the 4 minus 2x cubed plus x squared minus 3 plus 4 by x minus 1. And just for some left brains, sometimes if you bracket the question, it's a little bit easier for your brain to see what you're dividing into. What this question is asking is it's really backwards of multiplication. So this is asking if we take x minus 1 and we multiply by something, we want this to be the answer. The question is asking you to find the something. What did I times by x minus 1 to get this whole big long polynomial? How do you divide? It's called synthetic division. Yay! I do not sense the same excitement. Walk me through synthetic division. What do you remember from last unit? So what's the number that goes on the outside? Yeah, so in our head we put x minus 1 equal to 0 and then we solve for x, so x would equal 1. And you don't need to show that, I'm just showing for the first example where it came from. And what goes inside this division sign? Yeah, so the coefficient of the polynomial. So what's in front of the x to the 4? What's in front of our x cubed? Minus 2, followed by 1, negative 3, and 4. Step number 1, we drop the first number straight down. What do we do next? Perfect, so multiply by the outside. 1 times 1 is 1. Add vertically, so negative 2 plus 1, negative 1. Repeat the process. 1 times negative 1, negative 1. Add 1 plus negative 1. Repeat the process. 1 times 0. Add negative 3 plus 0. Repeat the process. 1 times negative 3. Add 4 plus negative 3. Now what we looked at when we were doing our oblique asymptotes is we only cared about the first two numbers because one was m and one was b. The reason that is because all our polynomials in here started with an x squared. And what happens when you do this division is whatever degree you start with, the answer is 1 degree less. Whatever polynomial degree you start with, the answer is one less. So we only had quadratics in here. That's why the answer was linear. This time we have something higher. What was our degree of our polynomial? What was the highest exponent? It was an x to the 4 was our largest exponent. That tells you the first number in the answer has to be an x to the 3. It always works that way as the answer is 1 degree less than what you started with. So our answer here is 1x cubed minus 1x squared plus 0x minus 3. What the heck is the 1 at the end? It's just the remainder. So what that tells us is this didn't divide evenly, and we're A-okay with that. Not everything in the world divides evenly. Well, I would never write the answer like this. How would we write the answer? X cubed. Perfect. And sometimes we just put a remainder of 1. Sometimes, and the book will do this, is we'll put it as a fraction over the binomial. So it will be 1 over x minus 1. It's just showing that that's the remainder that didn't divide. Okay, so sometimes we leave it just as 1. Sometimes we put it over the binomial. Either way, it means the exact same thing. It means it's a remainder of 1. So remember when we did oblique and I was like, everything after that doesn't matter? Now it matters. That's what it is. It was just the remainder left over when we were doing the division of the oblique. Take a look at example number 2. 30 seconds, turn and talk to someone, figure out what's different between 1 and 2. Why is there a note underneath there? What am I going to write down? So what is different from example 2 to example 1? The other class, they're officially caught up to you. So they started Unit 5 2 days before you guys did. So I taught this 2 days ago. And their answer was, it has different numbers. Yes, I didn't mean it has different numbers. There's something more to the difference between 1 and 2. What's the difference between 1 and 2? Sorry? The division, yes. What else? It's out of order. If we look at the order for the first one, it goes x to the 4, then the 3, then the 2, then x to the 1, then the constant. What's happening here? It's all mixed up. So my first note is the polynomial must be in order of the degree. The polynomial must be in order. And so that means the highest exponent comes first. And the constant will come last. All the ones we did in the last unit were always in the right order. I never gave you one that was mixed up because you didn't know this yet. Now when we do a synthetic division, the first thing I'm going to say is check the order. And when you put it in that division sign, it has to be the highest exponent all the way down to the constant. What goes on the outside for this example? What goes on the inside? So look through all those exponents. Which one's the highest? The x to the 4, so the coefficient of x to the 4 is 1. What has to come next? The negative 2, because that's your x cubed, followed by negative 8 for your x squared, 2 for your x, and negative 1. So let's just make a note here. This was the correct order. Okay, so we looked after the order before we did anything else. Fill in the rest of the numbers. Not cool. Agree, disagree? Did I make a mistake on purpose? I did not. That's the correct answer. What does the answer start with? Perfect. It's x cubed because it's 1 degree less. Plus? Perfect. Do I need to write 0x? No, we just leave it. Plus 2. Remainder. Ooh, minus. And again, you can just have a remainder of 7. I'm just going to write it like that because that's the way you're going to see it in the book. Yes, ma'am.
Why is 7 the remainder?
Because we add vertically. So minus 1 plus 8, 7. So like 8 minus 1.
But why isn't it in the other half?
Why isn't it in the other half? Why isn't it in here?
Yeah.
Because this is a constant, so this would have been 2 whole units. This is a partial unit.
Okay.
So it's a remainder left over that didn't divide evenly. This would have been even divisions. So it is part of the equation, it just gets stuck on the end.
Okay.
Example number 3, 30 seconds, turn and talk, figure out what the note's going to be about. What's different about example 3 besides the numbers are different, we know that. Okay, what's different? Well, there is a coefficient here, which we haven't seen, but that's actually not what the note's going to be about. I heard someone say, it's really short. Yeah, it's really short. Why? So there's only one exponent. We call that missing terms, and you need to be careful about missing terms. So if you have the highest degree and you have the constant, you have to be aware of anything that's missing in between, and we have to put a coefficient of 0. And what that does is just keep the placement in your division. So the note is watch for missing terms. Between the highest degree and the constant. So every time we do a synthetic division, the first thing I'm going to say is check the order. The second thing I'm going to say is watch for missing terms. Those are 2 things you need to consider. And we did this with oblique. We just didn't really talk about it, but we put the zeros when we needed them. Okay, so example number 3. What goes on the outside? Well, this is the first time we have a coefficient in front of the x, but it doesn't change the process. In your head, you're still just equating it to 0. So that gives us 2x equals 1. What does x equal? And that's okay. Fractions tend to freak us out. They make us think we've made a mistake. We can have fractions on the outside. Okay, the 8's going to come first because that's our x cubed. What about x squared? Is going to be 0 because it's a missing term. What about x? 0 because it's a missing term. And the constant? Minus 1. That's what this one means. Just beware of missing terms. We just put a 0 as the coefficient. Drop the 8 just like before. The fraction's no big deal because what's a half times 8? Add vertically gives us a 4. What's a half times 4? Adding vertically gives us 2. What's a half times 2? And adding vertically gives us 0. What does the 0 here mean? It means there's no remainder. And that just means it divided evenly. We we started with an x to the 3 or an x cubed, so this is going to start with an x squared, so 8x squared plus, perfect, plus 2. I don't write remainder 0, I just leave it. It's just blank. This shows me that there is no remainder and it divided evenly. Show me your thumb so far. How are we doing? Good. Find a friend if you feel social. Do 4 and 5. If not, I'll see you in a couple minutes and we'll talk.